Is it worth spending millions of dollars every year on technology, employing thousands of people, and maintaining data? A question which I very often ask freshers who are joining as data engineer is, tell me benefits of data warehouse. And almost everybody has mentioned that it helps in taking decisions. Now, when I dive deep into the question and I ask them that, can you give me some examples that how a data warehouse can help you in taking decisions, and I don't find any concrete answers. So in this video, I won't be teaching you SQL specifically, but my focus will be that by taking a sample data, how that data can help different teams in your business take decisions. What I have done is I've taken a DB ticket data in my Postgres database. The data model for this table is this. So you see there are a few dimension tables, fact tables. The keys are shared between the dimension and fact tables. All the DDL and the data files required for this data set is available in the description box below. You can download it, load it into your table, whatever database you are using, just load it into that table. Let's quickly go through the tables. We have a category table which has category of events, then calendar table which has the date information, then event, whenever an event occurs, that information is there. There is a listing table. Whenever the ticket is up for sale, this comes in the listing tables. Then we have a sales fact table which actually holds the information of all the tickets sold for the event. There's a user dimension table that stores information of all the users who come onto the website, purchase the tickets. Then we have information about the venue table, which stores information about different venue across North America. So there are 7 tables in it. There are a lot of records in the table, but what you are seeing right now is just the limit 20. So maximum of 20 records will come from a table. Now, intention of this video is not to teach you SQL only. How? By running SQL, you can generate data, and that data can help in taking decisions. So let's start with our very first query. So say you have an event coming up in New York and you want to see the details about it. So what we will do is select from event, T1, event. There's an event coming. Say we want to know more information about this event, the magic flute, right? So what I will do here is I will join it with venue T2, and let me take some columns from event and T2 dot. I want to know where exactly is this event going to happen. So I will take venue name, T2 dot venue city, T2 dot venue state. And I also want to see when this event is happening. So maybe I'll just refer to my calendar table. So on T1 dot venue ID equal to T2 dot venue ID. And I also want the date information. So I'll just join it with my date table. I'm putting it in double quotes date because date is a reserve keyword, and it is a very safe practice to put your reserve keywords. If you are using your reserve keywords as a column name or a table name, put it in the double quote so it is act as a title rather than a reserve keyword. So on T1 dot date ID equal to T3 dot date ID. And from the date, I will take some columns, calendar date. I think this should be enough. And maybe let me take a day also, because if it is a weekend or weekday, that will also help us in taking some more decisions. We'll see. And we want to know information about, let's say the magic flute. So the magic flute. And also let's say we want to know about when is this event going to happen in New York State, right? So let me run this query and see what is the output. So So this event is going to happen in Metropolitan Opera in New York City on 18th April, and the day is Friday. Say I have a business which hosts all these events and I want to promote this event now. I want to send a sales email to all the interested people. So what I can do here is, it's very simple. I will just go select star from users. And if you see the user, it has the details and then it has different information also, right? That what are their preferences. The user can come whether they like sports or theaters, like that. And here, if I see in the event, there is a category also. So let me bring the category also in the first query. Inner join, category, T4 on T4 dot category ID equal to T1 dot category ID. And from here, what I will take is T4 dot category group name description. So let me take category name. Okay, and I will run this query now. So you see here, it is a opera, right? So in the users field, I can see people have shared their preferences, whether they like opera or not. So here in my actual query, which I want to share it with my sales and marketing team, that these are your potential target customers. So now you want to share it with your sales team, that all the people who like opera. So here I will write where state equal to New York, because it is going to happen in New York, and like opera equal to true. And I will run this query. So these are the people who live in New York State and they like opera. And there is an event coming in New York State named Magic Flute, which is of category opera. So these are your potential customers. Go reach out to them, send them an email, give them a call, drop a SMS that there is an event coming. Would you like to buy tickets, right? So I think this use case is very clear to you, where how your data can help your sales team increase sales, get more revenue. Before going to the next use case, let's run a very generic queries, couple of very generic queries where we just want to know historically which all events are planned more often and which all states have more venues. So query is very simple for it. All you have to do is say event name from account star from event, and let me as total event group by. As I said earlier, all the non-aggregate column must always come order. All the non-aggregate column must always come in the group by clause. So total event descending. Let me just run this query. You see, this event is scheduled most, Mamma Mia, Spring Awakening, Macbeth, and similarly I would like to know more about the venues also. So if tomorrow I have to host an event, I know that which all states have more venues, and if I want to book a place, if I want to book a stadium to host an event, I know where exactly to go. So as total venues from venue group by venue state order by total venues descending. So just run this query. So okay, I see Nevada, Las Vegas has most number of venues, then New York, California. So if I have to schedule a event at last moment and I have to find a venue, then these are my popular states because they have a lot of options available to host. Alright, so after this generic use case, now coming to the actual use case, I want to find the profit made by each event. So whenever there is an event that happens, I make profit. but how much profit am I making? And this is required for my finance team and for the CXOs so that they can allocate budget to each department. So now my idea is that I want to calculate how much profit I am making from each event, right? So obviously I will start with my event from event T1, and I will pick T1 dot event name from this. Let me join it with sales table. T1 dot event ID equal to T2 dot event ID, and from sales table I want to see how much money I'm making, right? So T2 sum of, let me aggregate it, quantity sold as total tickets sold, sum of price paid as total price, sum of commission as total commission. Okay, so you see here what I am doing. I'm basically, for each event I'm just calculating how much profit I am going to make. Again, as I said earlier, all the non-aggregate columns should be part of your group by command. So let me run the query. Okay, so this is the output. I'm getting total tickets sold, total price, total commission. But as I said earlier, I want to see the profit, so that whichever event is most profitable, I should plan to do it more often. So let me create a derived table for it and choose the columns dt4 dot star, comma, dt4 dot total price minus dt4 dot total commission as total profit from dt4. And since I want to focus on profit, I will do order by total profit descending. Let me run this query. Okay, so I see this event has made most profit, 819,000 plus than this event. So I have a list of events that are making me most profit. So as a company who wants to increase your profit, I will focus more on these events that are making more profits to me. I hope this also use case is clear to you, right? Now, as a good data engineer, what you can do is you can further refine this data set, this report, so that the end users can take more better decisions. Obviously, these looks like some of the events that are making me more profit, but can I make it more specific? So what I will do now is, as the next step is, I will see that how many times each of these events were actually occurring. So what I will do here is I will copy this query and I will create a CTE with CTE as total events. As see, the reason is it could be that this event is happening more than this event, and that's why this event is making me more profit. But what is the average profit is what I want to see, so that the event which is not happening the most number of times but is making more profit. So the average profit is more in those events. I would like to focus more on such events as well, where the average profit is more. So what I will do now is I will just calculate in this CT, select event name from account star, from event group by event name, and I will name it as total events. Now here in my join, what I will do here is I will just create one more join with DT4. Inner join CTE total event. So I am just doing a join with the CTE on T5 dot event name equal to DT4 dot event name, and I will pick this column in my output. Not here, here. T5 dot has total events. So let me run this query and see the output. You see here, this event actually happens 92 times and has made this much money, commission and the profit. And these were the total tickets sold. And this one actually is lesser than third, but it has made more profit to me. So obviously, if I divide profit by events, I get the average from each event. So let me calculate that as well, where I will calculate the average profit, right? So here itself, I have all the information. What I will do here is, I will just do DT4 dot total. Let me just copy this. In some databases, you can use the derive column right away in the same block, but in Postgres, I cannot. So what I have to do here is I have to use the same logic again. This is my total profit divided by total profit divided by total number of occurrences. And this is my average profit, right? So what I will do here is I will also cast this as integer as average profit, and let me run this query now. So you see here the average profit is also here. Let me bring it here. So you see for every show what is the average profit. For this show I see the average profit is 10,900, which is way more than this one. So maybe I would like to focus more on this event because this generates more profit. This also generates more profit. This also generates more profit. If I am the team who is planning my next event, I will consider these events to generate more profit for the business. So I hope this use case is also clear to you, that how by running a SQL query, you generate a report, you get the data set, you share it with the relevant team so that they can plan their next events to make more profits. So this is how you are supporting the business by deciding which event to pick to generate more profits in the future. So if this is clear, then let's move to some more use cases. Okay. And in this use case, what we will see is, say you started an event and how much time it takes for an event to sell all the tickets. So we have a listing table where you list your tickets, and then we have a sales table where the actual sales happen. So in this use case, I want to see that for which event it took the most time to sell all the tickets, right? So again, what I will use here is from sales is my driving table, and then I will do a join with listing on T1 dot list ID equal to T2 dot list ID, and I will fetch column T1 dot sale time and T2 dot list time. So when the event was actually sold, and when the tickets were listed, and when tickets were actually sold. So this is what I am bringing from these two tables. And then we want more details about the event, right? What event was it? What was the name of the event? Then I will join with an event table here on T3 dot event ID equal to T1 dot event ID. Sales also has the event ID column, and from event table I will pick T3 dot event name. What was the name? And also to further give you more information, to further whatever team want to look into this information, the sales team, I may want to add some more information so that they can take better decisions. So let me involve the venue also, so that they know, okay, for this particular venue, the sales does not happen very quickly. It could be that the venue location is not very favorable, or the people who like that particular category of event are not living there in that particular venue, right? Not living near that particular venue. So next time when I am hosting that event, I will pick a location where the people who have already expressed interest that particular category are more there, right? So something like that. So I will do T3 dot venue ID equal to T4 dot venue ID, right? And from venue, let me pick venue name, venue city, and venue state, right? And as I said earlier, I want to get more information, so let me bring the category information also, so that what category of event it was that the ticket sale did not happen very quickly. So T3 dot category ID equal to T5 dot category ID, right? Now this looks good. I will get T5 dot cat group, T5 dot category name, and let me bring the category description also. Now I want to generate a derived column, and that is how much time actually it took. T1 sale time minus T2 dot list time. So when the actual tickets were listed on the website and when it was actually sold. So this is information which I want. I will just order by time to sell descending. So what I will do is I will just run this query and I will share this output with my sales team, so that they can know that, okay, what was the event, and it took like 59 days to close all the tickets. This was the venue name, this was the event, the sale time was listed, the tickets were listed on 16th February and the last ticket was sold on 16th April. So almost 2 months it took. This was the event, it happened in this venue, and it was a category musical theater. So next time when I am planning this event, maybe I'll not choose this venue. I will choose somewhere else where more people have expressed interest in this category group or this category, right? And I can plan my shows in a better way. So this is how I can help my planning team, that next time when you are planning an event, pick a venue which may result in tickets getting sold quickly and you can make more profit, right? So if this use case is clear, let's see one more use case. So in this use case, what I will do here is I will see who all users are actually buying tickets to the same event, right? So I have a buyer ID here and I have event ID here. So my idea is I will identify the users who are frequently buying together tickets for the same event, so that if tomorrow one buyer buys the ticket for a new event, I will send a mail to the other buyer that, okay, these are the events which are happening and you may be interested. So let's see with an example and things will become much more clear. Okay, so let me write this query. I will select and then I will come to sales T1, inner join sales T2. I'm going to do a self join here because I want people going to the same event, but they are not the same buyer, they are different buyers. So it's a straightforward query where the buyers are different but the events are same. So what I will do is T1 dot buyer ID, T2 dot buyer ID, and count star as total events together. And then, as I said earlier, all the non-aggregate columns should come in group by. And let me do order by total events together descending, and I'll run this query. So what I can see here is this buyer and this buyer have bought a ticket for 4 events. So there are 4 events where both of these buyers actually went. Similarly for this also, there are 4 events where both of these buyers actually went together. So now instead of these IDs, let me bring some name so that you can relate more. Rather than IDs, it is always better to look into the name. It makes more sense to us as a human. So what I will do here is I will copy this. I will create CDs and let me bring the respective name of the users. Okay, so inner join, so it will be inner join with users, obviously, on T1 dot user 1. Let me give a proper name here, user 1, and as user 2, T1 dot user 1 equal to T2 dot user ID. I will again join with the users table, and this time on T1 dot user 2 equal to T2 dot user ID. Yeah, and here in the main select block, I will obviously fetch T2 dot first name, T2 dot last name, T3 dot first name, T3 dot last name, and T1 dot total events together. So now let me run this query and see the output. And let me order by also. So we see who all are the people who frequently buy the tickets for the same events. Alright, so here it is. So Iris, Francis, Nola, Keller. So when Iris Francis buys a ticket, Nola Keller also buys a ticket, and it has happened 4 times for different events, right? So next time, if I have a team that basically recommends upcoming event to the user, and I see Iris is buying a ticket, I will be sending an email to Nola and Leslie also that there is an event coming up, you may be interested. So this kind of data can help a team who is building a recommendation engine that okay, if one person is buying a ticket for an event, you can suggest the same event to similar person who have gone to the same event in the past, right? Now one homework for you here is, you see Iris Francis, Nola Keller here, and I see Nola Keller and Iris Francis here. So this is getting repeated. What I want you to do is, as a homework, write a query where this group and this group comes only once. So either you keep Iris Francis Nola Keller, or you keep Nola Keller Iris Francis. Both of them should not come in the output. So this is a homework for you. Write a SQL query where you get either this or this, because these are repeating groups. The first name 1 actually becomes first name 2 in another row, which we don't want. So it's a homework for you. Write a SQL query where you can fix this. So I want only one combination in the output, not both. Alright, so if this use case is also clear to you, what I want you to do now is, I want to see average price sales for each event, and then I will check average list price for each event, and then I will identify the sellers who are actually selling the ticket 5 times more than the average price. Now, why that information is important is maybe the fraud team in my business, they want to see the sellers who are actually maybe at the last moment they are increasing the price and they are trying to sell a ticket at a very high or expensive cost, which I don't want. I want my ticket cost to be at the same level, roughly at the same level. Somebody is coming and selling the tickets at 5 times more the average price. I have to flag those sellers. Maybe I'll ask some questions, or maybe I'll just ban those sellers from my platform, right? So let's start with this use case. First thing I will do here is I will calculate the average price for each event. So event ID, comma, sum of price paid, sum of quantity sold, and let me just convert everything to integer as this, as integer, as average price sales. And always all the non-aggregate columns must go into the group by clause. So for each event, what is the average sales price is I have with me, right? Now what I want to do here is I will calculate something similar information from the listing table. Now listing table has listing of the tickets, and this time I want to get some more ID, and this time I also want to get the seller ID, average price per ticket. And again, let me cast this as integer for the sake of simplicity, and I can name it as average price list. Okay, and I will again, all the non-aggregate columns should come in the group by clause. So I'll run this query and show you the output as well. So event ID, seller ID, average price list. So now I have two blocks. One is average sales price and the other is average list price per event per seller ID. And now all I have to do is just join these two. So I'll create a CT for it with sales average price as, and another CTA is list average price as. And now I just want to do select star from CTE1 T1 inner join list average price T2 or T1 dot event ID equal to T2 dot event ID, and I set a condition, right, that T1 dot average price into 5 times is less than T2 dot, so average price of listing is greater than 5 times of sales price. This looks good to me. So you see the output of the query here. The average price of listing, this was the sales price for this event, and this is the list price for this event by this seller ID. So maybe I'll just go and reach out to this seller ID and look at this price, 249,1902. So all these sellers are actually listing the tickets 5 times more than the average price sales, and I definitely want to reach out to these sellers, send them a warning email or even block them that you are not supposed to sell tickets at such a high price on our platform. So all the sellers should have a equal chance to sell their tickets, and at the last moment it could be that they are holding the tickets, and at the last moment they are putting it on the platform at a very high price, and this actually destroys customer experience and the other sellers experience as well, and we don't want it for our business. It's not good for our business. So we may want to send warnings to these sellers that don't put so elevated prices on our platform, right? So I think this use case should also be clear to you that okay, and so I think this use case should also be clear to you that how we can make the business more equal for all the sellers and improve the customer experience as well, right? Let's do one last round of let's do one more use case before I wrap this video. So here you see, right, all the user details are here. Now I want to see that are there any users who are using the same email ID. So it could be that they are part of the same family using the same email ID to book the tickets, and we may want to give them a family discount or something like that, right, where we want to come up with a plan where they can do a subscription at the family level. So they should have at least 2 people from the family registered to our website. And to find out that, what we can do is, we don't have the exact address here, house number and everything, but we have the email. So let's try with the email first, that to see okay how many people are using the same email ID but their first name and last name are different. So it's a very simple use case. What I will do is, from users, and I will just get their email ID. Email from users, group by email, having count star greater than 1. So this will give me all the email IDs which have more than 1 occurrences in the users table, and I just want detail of all the users where email in. That's it. So I'll use a subquery here. I'll run this query, and let me do one more thing here. Order by in the output so that it looks okay. So if I see here, this and this same email ID but 2 different people, even in a different state, are using my account with the same email ID. The profiles are different. It's just like in Netflix, YouTube, we create different profile. Similarly here, the same email ID but the profiles are different, and I see that their preferences are also different. Somebody, what one person like, the other person does not like, and that makes sense also, right? That depending on your preferences, you have created different profiles, so that when I'm sending an email for marketing or an upcoming event, I know it could be the same email, but there are different people using that same email ID, different family members, so I can address that particular family member rather than sending it a blank email. So if I'm sending an email for a sports event, I will write Dear Lenore, right? And so I will write Dear Mr. Benjamin, right? Or if I am sending an email for some classical event, then I will not address it to Mr. Benjamin. I will refer it to Mr. Gold, right? So yeah, so it's a simple use case where you can identify the different family members and come up with some subscription that okay, for all your family members you pay a monthly subscription of this, and for XX events you will get a free entry or a 50% discount. So I hope the intention was not to teach you SQL in this video. The intention was that to take a very simple example and teach you how your SQL and whatever the data you are generating is helping take a lot of good decisions and which are helping business. How your technology, how your SQL, how your data engineering skills are enabling business to generate more revenues and more profits, right? Now this was a very simple use case. Consider you are working for a business which is in fintech, right? Now say a fraud case, right? If you do not detect fraud case in a timely manner, a fraud case itself can result in losses of millions of dollars. So your question whether it is worth spending millions of dollars every year on technology, definitely it is yes, it is totally worth, because with your queries, if you can generate a report that can enable your fraud and risk team to stop a potential fraud happening and saving millions of dollars for the company, it is totally worth, right? So, and you are helping your sales team, you are helping marketing team, you are helping your recommendation engine team, you are helping your fraud and risk team. So all the aspects of the business are covered using your data warehouse. So data is actually very important. And in this video, I just gave you a very small example, a very simple example to show you that how your data is actually helping the business take decisions and get more revenues and make more profits. So if this, like, it took me more than 2 months to research for this video, get the data set, what all the use cases I wanted to cover, how to make it very simple so that a beginner can also understand. So if you really like this video, I will really appreciate you dropping a comment, liking this video, sharing it with your friends. It helps with the YouTube algorithm, and it also motivates me when I see a lot of you people coming, watching my video, dropping good comments. So please do support me.